All right, we are starting on chapter 4. So when I save things, this chapter, it's going into my honors pre-calc chapter 4 folder. We are starting trigonometry, and in order to start trigonometry, we need to understand radians and degrees. I'm not quite sure how much of this got shortened last year because of the quarantine, so I'm going to kind of go through everything. Hopefully you remember some things, and you can always, fast forward if I'm taking too long. So just talking about angles in general, we are going to have the angles sitting on an x and a y axis. We're going to have an initial side. That initial side would be the ray that starts the angle. And then we're going to rotate that ray. We're going to keep that ray there, but we're going to rotate, and we're going to have a new ray. And that new ray, after the rotation, is called the terminal side. So we have our initial side, a rotation, and then the terminal side. And then that angle that is formed will be the angle that we were talking about at some point in this chapter. A lot, actually. Usually we're going to call it theta. It was really messy. I'm going to undo that and fix it. It's a Greek letter, theta. I'm saying theta. Theta. Okay. If you are graphing a positive angle, it's going to rotate clockwise. I'm sorry, I can't read. Counterclockwise, which you can think about starting from our initial side. If I rotate up and around, that's going to be positive. Now, if I rotate down and around, that's going to be a negative angle, and that's rotating clockwise. Talking about the whole circle itself, if we rotated all the way around one full time, that would be 360 degrees. Now, we are also going to talk about angles in radians. So when I talk about degrees or radians, I'm gonna compare that to something that might make more sense to you. If I had a ruler and I asked you how long is that ruler, what's the measurement of that ruler, a lot of you would say like 1 foot, or you would say 12 inches. But if you go to a different part of the world, they may say something like 30 point, I don't remember what it is, maybe 4 or something, maybe 30.5, I don't know, I didn't look it up ahead of time, centimeters. So this ruler can be measured in inches, or it can be measured in centimeters, and we understand that both of those measure the same thing. They measure length. So what I have is I have degrees and I have radians. And both of those measure the exact same thing. They measure the rotation of an angle. They're just measuring in different units. One unit is called degrees, another unit is called radians. As you get to higher level math courses, we use radians more often than we do degrees. However, degrees are used just kind of more in real life situations in our country. So if we make one full rotation all the way around the circle, that's going to be 360 degrees, but it's also going to be 2 pi radians. So what you need to understand is that these two numbers are equivalent. They are equal. They're the same amount of measurement. They just are in different units. If we were going to go halfway around, if we were just going to go starting here, we were just going to rotate halfway around in half a rotation. In degrees, that would be 180 degrees. In radians, that would be pi radians. And we can keep breaking it down further as well. If I wanted to just do a quarter in degrees, that would be 90 degrees. In radians, that would be pi divided by 2, or a half pi, but we're not going to write it as half pi. We're not going to write it that way. We're going to write it as pi over 2. I'll tell you a little bit why in a moment. So we need to understand the conversion between these two. Now, I can type pi in my calculator, or I can type 2 pi in my calculator. Let's see, if I typed 2 pi in my calculator, it's going to be an irrational number. It's going to go on forever. But if I just rounded it, it would be approximately 6.28. So all the way around the circle is approximately 6.28 radians, which is 2 pi radians. So these numbers are equivalent. They have the exact same units. It's just one of them has the pi approximation multiplied through, and the other one has the pi as a symbol. You do need to understand both of these. So if I take half of 2 pi all the way to the other side, we are sitting at pi, which is half of 6.28, which pi is 3.14. Now, what a radian is, the definition of a radian, I'm going to put another circle over here. Definition of a radian is when we measure the radius of a circle. So here's a radius. If I were to take that radius measurement and I were to maybe bend it around the side of the circle, and I were to find the exact same measurement around the side of the circle, and then I drew the angle, the terminal side back, this theta would be 1 radian. So 1 radian is formed when the initial side radius is the exact same length as the arc length that forms that terminal side. So that's why they're called radians, because they're measured from the radius. So if we were to put in the measurement of 1 radius around the circle, that would make an angle of 1 radian. If we were to pile up a second radius around the circle, that would make the same angle as the first one, but we could add them together and say that is 2 radians. If we were to add a third radian on, that would be approximately right here. This picture is not drawn very precise. It'd probably be a little bit closer, but approximately here would be 3 radians, which that is why the x-axis here is at 3.14. It's just a little bit past 3 radians. And then we can add on another radian, and there'll be 4 radians, and then 5 radians, and then 6 radians, and then the extra little bit would be about 0.28 of a radian to make the full 2 pi around the circle. If you see something like, if you see the number 10, how do you know if that is degrees or radians? So looking at 10, I would have no idea. So what we have done is we've kind of come up with an idea that says if it is degrees, there will be a degree symbol. If it's radians, there will not be a degree symbol. So if I have the number 10, if we're talking about an angle, say measure of angle A is 10 degrees or measure of angle A is 10. If we're talking about the measure of an angle and there is a degree symbol, then we know it's degrees. If the degree symbol is not there, we have to know it's radians. Just because there is a pi in there does not make it radians. So I could have degrees that are 3 pi degrees. Okay, that's 3 times 3.14 as degrees. That could happen as well, and that would be degrees. Just because there's a pi in it doesn't automatically make it radian. All right, in these circles, I'm just going to talk about how we can find specific radian measurements quickly and easily. And you'll have to kind of use this to find some other answers. Let's say right here's our initial side. If we go all the way around once, it's going to be 360 degrees. But now I'm going to do this in radians because I know we can do, I'll just do this first one with degrees, but we're really going to focus on radians. So this one would be 90 degrees. This one would be 180 degrees, and then we should know that this one is 270 degrees. Now, I'm not going to really use the degrees so much. I'm going to do the radians. So if I think about radians, the way I do it is I think about the top half of the circle. And I'm going to take these numbers in degrees and I'm going to write them as radians. So 90 degrees plus 90 degrees, these are each 90-degree sections, this one and this one, both 90-degree sections, they equal 180. We know that 180 is pi because 360 is 2 pi. So 180 is halfway around the whole circle. Now I'm just looking at the pink section. There are 2 sections in this top section that is pi. So if I want to find the measurement of each of them, they are equally spaced. I want to find the measurement of each of them. I take pi and I divide it by 2 because there are 2 equal sections. Each of these sections would be pi over 2 in their measurement by themselves. Now if I'm talking about a terminal side, we would do pi over 2 here, and then we would add on a second pi over 2 pi over 2, which reduces to give us pi. We can continue that pattern. We would add on a third pi over 2. So 3 pi over 2 is the radians for the third division, I guess. And then the fourth one would be 4 pi over 2, which reduces to 2 pi. Now I could keep going. I could add on another pi over 2 and get 5 pi over 2. 5 pi over 2 and pi over 2 have the same terminal side. They both have that same line where the angle ends. And I could keep adding on forever if I want. I could do 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over, I can keep going. I can also go the other direction. I could go negative pi over 2 and negative pi and negative 3 pi over 2. So I can go the other way as well. I just want to show you that we're just going to count by pi over 2's in this case. All right, the next circle, I'm going to take what's there and I'm going to cut the pieces in half. And we know that this is 0 degrees or 360 degrees. As a radian, it would be, well, 0 radians or 2 pi radians. Over here, this is 180 degrees. As radians, it's going to be pi. So I'm going to take the top half, which is pi. I'm going to take that pi, and we're going to shade it in so everybody knows that I'm only talking about the top half right now. I'm going to say how many little evenly spaced sections are there in the top half. 1, 2, 3, 4. There's 4 sections in the top half. So each of these sections is going to have a measurement of pi divided by 4. So we've got 1 pi over 4. The next one is going to be 2 pi over 4. However, this one I've already named in the previous pink circle as pi over 2 because it does reduce to pi over 2. Then we've got another one, 3 pi over 4. And then we've got 4 pi over 4. But I have already named this side pi because 4 pi over 4 is is pi. Then we've got 5 pi over 4. And then this one's already named 3 pi over 2. Which would be 6 pi over 4, 7 pi over 4, 8 pi over 4, and we could keep going. There's only 4 of these that I actually reduced. No, rephrase that. Only 4 of these that I did not reduce. There's only 4 of these that end up staying as pi over 4. And 1 of them per quadrant that actually stay as pi over 4. That's really helpful. And the next graph, I'm going to not divide it in half. This is going to take me a little extra second. I'm going to divide the top half. Oh, I'm just going to color it in first. Somebody had the wrong marker. Color it in first. Okay, now I'm going to divide the top half into thirds. So if I divide the top half into thirds, we've got 1, 2, 3. That 90 degrees is not an ending section. So if I'm taking pi and I'm dividing it into 3 equal places, pi over 3 will be my first section. My second section will be 2 pi over 3. Then 3 pi over 3 is pi. And I'll just continue that down here. We've got 4 pi over 3. We will have 5 pi over 3. And then 6 pi over 3 reduces to 2 pi. So for this one over here, we have 4 angles that stay over 3, 1 for each quadrant. Now there is one more group, and I'm going to put it on the same circle as the pi over 3s. If I take, oh shoot, I always forget to switch the marker back. If I take these sections and I half them, and now I count the amount of pieces on the top, we've got 1, 2, 3, 4, 5, 6 evenly spaced pieces. So the first piece on top in pink is going to be pi over 6. And then we go to pi over 3, which would be 2 pi over 6. But that reduces to pi over 3. Then we've got 3 pi over 6, but that reduces to pi over 2. 4 pi over 6, but that reduces to 2 pi over 3. Here we have 5 pi over 6. That one does not reduce. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And then 12 pi over 6. So the same rules as the other ones. There are only 4 angles that stay over 6, 1 in each quadrant. So this is going to help you identify some radians quickly. And the reason why we are choosing these particular radians, I'm just going to put off to the side here. Well, the reason why we're choosing these particular radians is because of what they equal. Let's see. I think you could probably figure out the very first one. We're using the values of 90s because those are on the quadrants. The other ones, the 4s. If I take 180 degrees and I divide that by 4, it's the same thing as pi divided by 4, that is 45 degrees. If we take 180 degrees and we divide it by 3, same thing as pi divided by 3, that is 60 degrees. And if we take 180 degrees divided by 6, which is pi over 6, that is 30 degrees. And these 3 angles are very important when we start talking about right triangles, which is what we're about to start talking about. When we start talking about right triangles, 45s, 60 degrees, and 30s are very important. They're very special. And if you do not remember from a previous course, why are they so special, you will be finding out very soon. Special. All right, example 1. Third rotation clockwise around the whole circle of the circle. And it's asking us to draw it. Initial side, that you will draw an arc. Oops. We'll draw an arc, and you will draw the terminal side. Keep trying to change my color and I don't hit it hard enough. There we go. And we'll draw the terminal side. Now to figure out the measurement for degrees, I take the full 300. Okay, and then for radians, we'll take the full 2 pi, we'll multiply it by 1/3, and we get 2 pi over 3. Now these should be equal. The next one, 7/4 rotation. Maybe I'll do the math first. For degrees, I'm going to do 360 times 7/4. So that's going to actually give me, I forget. I think it's 630. Yeah, 630. 630 degrees. If I do the radians, I'm going to do 2 pi multiplied by 7/4, and I will get 7 pi over 2 radians. Sorry. And then we also have to graph it, so we'll start with our initial side, and then we'll do an arc. Now this arc is bigger than, oh, and we're doing, oh my gosh, I totally forgot because I didn't do the picture first. This is clockwise, so this should actually be negative. Should have started with negative, 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 just because it goes the other direction. Almost missed it. Okay, so now we are going in a negative direction, but we're going more than a full circle. So how I show that is I'm going to go all the way around once, and then I will finish it, and it ends up being right here when I'm done. So now anybody who looks at my paper can tell that this angle that I was given was more than 360 degrees. They can see me going around more than once. It's just really vocabulary. Coterminal means it shares the exact same terminal side. So here's the picture. Here is, so the first one's 30 degrees. Here's 30 degrees about. Now if I were going to, instead of going positive 30, if I were going to go negative, I could get to that exact same terminal spot by going negative. Figure that out by taking 30 and subtracting 360. That's how I would do that mathematically. If I'm starting at 30, I'm going to go all the way around the other side, subtract 360. So to find the negative, we take 30 minus 360, so negative 330. And then to find a positive, do it in green. I'm doing the positive. We go 30 degrees, and then we go all the way around again. So that all the way around again is that extra. And for a positive, we would add negative 45 plus 360. We would get 315 degrees. Okay, so I think this is repetitive, this is repetitive. Question E, as soon as I see pi over 3 and then I do not see a degree symbol, this tells me I'm using radians. And if I'm using radians, I'm not using 360. So instead, I'm going to use 2 pi. I'm going to subtract 2 pi. In order to subtract these, we need a common denominator. Pi over 3 minus 6 pi n pi over 3, and there's our positives. And then question F would be just like question E, so I'm not going to repeat that. All right, the next thing is a graphing calculator question. So if you don't have your graphing calculator with you, go grab it, pause the video, and then I'll pick up. All right, so you may have done degrees, minutes, and seconds last year, DMS, degrees, minutes, and seconds. If you did not, it's really easy to use on your calculator. Just how it is done without a calculator is we do know that there's 60 seconds in a minute and 60 minutes in a degree. So it's not time. It's just basically taking our degree and that 1 degree, dividing it into 60 equal little spots, and then taking each of those 60 and if we could take that 1 degree and divide it by 3,600, that is going to equal 1 second of a degree. So we're getting like really precise with degrees. So this would be used in real life application if angles are important for a job. We would probably use degrees, minutes, and seconds. I know that in surveying they use it. So here's an example, 25 degrees, 15 minutes, 45 seconds. What this means is 25 degrees plus 15 over 60 minutes plus 45 over 3,600 seconds. And you could add those as decimals to find that this answer should be 25 So once you're on your calculator, just get mine zoomed in here and focused. Okay, when you're in the calculator, above it says angle. So we're going to go to the angle button, and you're going to see there's the degree symbol. Right underneath it is that first apostrophe. So we're just going to do apps, which is angle 2, and then the last was 45 seconds. But there isn't there's the seconds right there, alpha plus sign, and you'll see it puts the seconds in there. Once you have that typed in, you hit enter, it goes ahead and it changes it to decimal form for you. So if you're given this and you need decimal form, that's how you're going to. Another question is use the calculator to convert 99.025 degrees into degrees, minutes, and seconds. So we're taking decimal form and we're changing the button again, so second, apps, and you can see question or choice 4 is turn it into DMS. So 4 and then to 99, 1 minute, 30 seconds. found. So you need to know. Now this is just asking which quadrant the given angle is found and to sketch it. So I'm going to go through a few of these. We've got 110 degrees, so I'm going to sketch. Here's my initial side. My terminal side is about here. It's bigger than 90. And I've got the rotation angle, or rotation arc in there. So I've sketched it, and then what quadrant is it in? It's in quadrant A. That's going to put us in quadrant 1. All right, so the stuff we did on the front with radians where I was dividing up the pi, that is helpful when we get to a question like D, 7 pi over 8. So we have to sketch that. So I'm going to think about and I'm going to divide it into 8 equal sections. And then after I divide it into 8 equal sections, I'm going to start at my initial side, and I'm going to rotate it through 7 of those 8. Rotate it through 7 of the of the pi over 8s. So that's going to tell me that my answer is in quadrant 2. Negative 2 pi over 3. So we're going to go in a negative direction. We're dividing the pi into 3, and we are doing 2 of them. So we're going to start here. We're going to go negative 2 pi over 3. That's going to be in quadrant 3. And our last example says negative 5 radians. So you'll see that there isn't a degree symbol, so it's telling us this is the decimal of but if I went halfway around, I'd go to negative pi. But we're using decimals. So 6.28, 3.14. So if I went to here, that would be half. Sorry, I forgot my negative sign. That would be half of 3.14, which is negative 1.57. If I went to this axis, the positive y-axis, that would be negative 4.71. So once I have those values in there, now I can figure out that negative 5 is going to be about here. And it's going to rotate this way around. And that is the first quadrant. All right, the next section, 2 positive angles. Alpha and beta are complementary if their sum is pi over 2. So complementary, we remember from geometry, hopefully, would be the sum would be 90 degrees. Well, now we're doing it in radians, so 90 degrees, pi over 2, those are equivalent. 2 positive angles are supplementary if their sum is pi. So again, pi is 180 degrees. If possible, find the complement and the supplement of the following angles. So if I know one of the angles is 2 pi over 5, and then I add on the other angle, which maybe it's beta, I should get pi over 2. This is for the complement. So we're going to solve for beta. We're just going to take pi over 2 and subtract 2 pi over 5. I need common denominators. So 5 pi over 10 minus 4 pi over 10 is 1 pi over 10, or just pi over 10. So that is the complement. And then we're going to do the supplement, which is fives. Next one, same work. We're going to find the complement. That's the supplement here. I'm going to find the complement by doing pi over 2, subtract 4 pi over 5. Need a common denominator, so 5 pi over 10, subtract 4 pi over, 8 pi over 10, and I get negative 3 pi over 10. This is not an acceptable answer because complementary and supplementary are two positive angles. So this would mean that it does not have a complement. No complement. That doesn't mean it doesn't have a supplement, so we find our supplement, pi minus 4 pi over 5, which would be 5 pi over 5, minus 4 pi over 5, which is pi over 5 for the supplement. The last section is converting between radians and degrees. So to convert, when we do like the special ones, we are going to have all stuff memorized when we're out. We would use converting would be if we don't have special ones memorized. All of these are special ones, but I'm just going to use them just to show you the conversion formula. So to convert, you are going to say, you're going to multiply by a value 1. So it does not affect the value of 135 degrees. But what it's going to do is it's going to change the units. So we're just converting our units. Right now I have a units of degrees. To convert it so it's not degrees anymore, you have to divide by degrees. And we want to divide by degrees and multiply over 180. Now what happened to the degree symbols is one was on top, one was on the bottom, so they canceled each other out. To reduce this, you can reduce that by hand. I am using my calculator. I'm dividing 135 by 180. I'll show you real fast. I'm just dividing 135 by 180, and I do math, enter, enter, and it reduces it for you. When we do this, and they're horrible numbers that you're dividing and not these easy numbers, it would be nice to use your calculator if possible. So I'm just going to do it with my calculator this time. 3/4. So this would be 5 over 4 radians, and we have converted it. So if there's degrees, you are going to divide by degrees, which means multiply by radians. That is so that the degree symbols will cancel and we'll get radians when we're done. We've got 540 pi radians over 180. Typed that in my calculator, reduced it, and I got 3 pi. One thing that I went over really fast that you might not have noticed, I did not type pi in the calculator. If you type in pi, you are not getting a fraction. You got to type in the numbers that are not pi, and then just put the pi there when you're done. And then negative 270, that works the exact same as the other ones. You just have a negative number when you're done. For this one here, if we've got 180 degrees over pi radians. So this time we're taking radians and we're converting it to degrees. So that's why degrees is on top and radians is on the bottom. I'm trying to tell you this so you don't really have to remember which one goes on top when. You just have to make it so that the units cancel out, and then you have which one goes on top. So this would be negative 180 pi over 2 pi. And simplifying that, we get negative 90, oops, and I forgot my degree symbol, negative 90 degrees. Or maybe negative 90 degrees, either is fine. I'm going to skip that one because that's basically the same way. I'm going to go to this one over here at the end that is in radians, but it is not with pi, it's in decimal form. So we can still convert it. We've got our 2 radians. We're going to multiply that by 180 degrees over pi radians. That way our radians cancel. Our next step is going to be 360 degrees over pi. And this is basically the answer. We've got 360 divided by pi degrees. Now if I type that in my calculator, I'm going to get an approximation. But this is the exact answer. I'll go ahead and type it in and tell you the approximation. But this answer, the first answer, is the more exact answer. It's approximately 114.592 degrees. But this answer here is more exact. Okay, so that was a very fast review of radians and degrees. If you have any questions, send me a message. And have a great day. See you soon. Stay safe.